NASA has been studying Mars for decades, sending orbiters to circle the planet and rovers to slowly move across its surface, collecting information piece by piece. For years, this steady flow of data helped scientists form a clear picture of what Mars is supposed to be. China arrived much later with newer instruments, a different mission design, and a fresh perspective on the same planet. They were studying the same rocks, the same soil, and the same atmosphere. But when their data was compared with NASA's, something didn't quite line up. The planet China was describing didn't fully match the Mars NASA thought it understood. And that difference, small as it may seem at first, could change the way we think about Mars altogether. Mars is not just another planet in our solar system. It holds a special place in science because it helps us answer some of the biggest questions we have about life, water, and the future of planetary exploration. Scientists study Mars to understand how planets change over time and whether worlds like Earth are rare or common in the universe. Because of this, researchers expect consistency. When multiple missions study the same planet, especially with advanced instruments, the data should point in the same direction. Small differences are normal, but the overall story should remain the same. That's how scientific confidence is built. So when data from two major space programs doesn't fully agree, it raises concern. It suggests that something important might be missing from our current understanding. If Mars behaves differently depending on where and how it's observed, then the planet may be far more complex than we assumed. And if we don't fully understand Mars, a planet we've been studying for decades, it forces an uncomfortable question. What else in our solar system might we be misunderstanding as well? For decades, NASA has been shaping how the world understands Mars. Long before rovers touched its surface, orbiters mapped the planet from above, revealing ancient river channels, dry lake beds, and signs that water once flowed freely across the Martian landscape. These discoveries transformed Mars from a lifeless red dot into a planet with a deep and complex history. According to NASA's data, Mars was once warmer and wetter, with an atmosphere thick enough to support flowing water on its surface. Rivers carved valleys, lakes filled craters, and the planet may have looked very different from the cold desert we see today. But over time, Mars lost much of its atmosphere, its surface water disappeared, and the planet slowly became inactive. Modern NASA missions describe Mars as largely stable in the present day. While the surface still shows evidence of a dramatic past, most geological activity appears to have ended billions of years ago. Volcanic regions cooled, tectonic movements stopped, and Mars settled into a long period of quiet. Rovers like Curiosity and Perseverance have confirmed this picture by studying rocks that formed during Mars' ancient water-rich era. They've found minerals that only form in the presence of water, strengthening the idea that Mars once had the conditions needed for life. But at the same time, NASA's findings suggest that those conditions no longer exist today. In short, NASA's version of Mars is a planet that had its moment, a world that was once active and dynamic, but eventually lost the energy needed to keep itself alive, a planet frozen in time, preserving the story of its past, but offering very little evidence that anything significant is still happening beneath its surface. China's Mars mission arrived with far less history, but with something just as important, a different way of looking at the planet. While NASA's exploration had been built over decades, China's approach was more focused, combining orbiters, landers, and rovers designed to examine Mars as it exists today, not just as it once was. When China's instruments began sending data back to Earth, scientists noticed details that felt slightly out of place. Certain surface features appeared younger than expected. Some geological formations didn't fit neatly into the timeline NASA had established. These weren't dramatic discoveries on their own. but together they hinted at a planet that might still be changing in subtle ways. Even more intriguing were signals suggesting activity beneath the surface. Nothing obvious, nothing dramatic, just small inconsistencies. Patterns that didn't fully match the idea of a planet that had been completely quiet for billions of years. These observations weren't part of a mission designed to challenge existing models, yet they quietly did exactly that. What made this especially interesting was that China wasn't trying to rewrite Mars's story. Their data simply reflected what their instruments were seeing. But when compared with NASA's long-standing picture of Mars, it raised an uncomfortable possibility that parts of the planet might not be as inactive as previously believed. And this is where the tension begins to grow. Because if China's observations were accurate, then Mars wasn't just a frozen record of the past. It was a planet still holding on to traces of movement, change, and unanswered questions beneath its surface. At first, the differences between NASA's data and China's didn't seem alarming. After all, Mars is a vast planet, and no single mission can see everything at once. Different landing sites, different instruments, and different scientific priorities can all produce slightly different results. But as scientists began placing the data side by side, a pattern started to emerge. NASA's observations described a planet that had largely settled into geological silence, while China's findings hinted at regions that didn't quite fit that description. It wasn't a direct contradiction, but it wasn't a perfect match either. The more researchers looked, the clearer it became that Mars wasn't telling a single unified story. Some areas appeared ancient and unchanged, while others showed signs of processes that seemed far more recent. It was as if different parts of the planet were operating on different timelines. This raised a troubling question. If Mars behaves differently depending on where you look, then our global models of the planet may be oversimplified. We may have been describing Mars as one consistent world, when in reality, it could be a patchwork of environments, each following its own rules. And once that idea takes hold, it becomes impossible to ignore. Because if Mars isn't as uniform as we believed, then the data mismatch isn't just a technical issue. It's a signal that we may have misunderstood the planet at a fundamental level. When the data from NASA and China is placed side by side, the difference becomes harder to ignore. NASA's long-standing view presents Mars as a planet that has been largely inactive for billions of years, preserving its history in rock and dust, but showing very little evidence of ongoing change. China's observations, however, introduce subtle inconsistencies into that picture. Certain surface formations appear less eroded than expected. Some geological features suggest they may have formed more recently than NASA's models would predict. These aren't dramatic signs of volcanoes erupting or rivers flowing, but they hint at processes that may not be entirely finished. This doesn't mean one space agency is right and the other is wrong. Instead, it suggests that Mars itself may be responsible for the confusion. The planet may be far more uneven and unpredictable than our simplified models allow. Parts of Mars may have gone quiet long ago, while other regions could still be slowly evolving beneath the surface. What makes this especially difficult to explain is that both datasets are reliable. The instruments worked as intended, the measurements were verified, and yet the conclusions don't fully align. That leaves scientists in an uncomfortable position, forced to accept that Mars is not behaving in a way that fits neatly into existing theories. And this realization leads to a deeper concern. If Mars can present two different stories at the same time, then the problem isn't the data. The problem is our understanding of the planet itself. One possible reason for the mismatch is location. NASA and China didn't study the exact same places on Mars. The planet is enormous, and conditions can vary dramatically from one region to another. What looks inactive in one area could behave very differently just a few hundred kilometers away. Another factor is instrumentation. Each mission uses tools designed with specific goals in mind. Some instruments are better at reading surface chemistry, while others are more sensitive to what lies beneath. It's possible that China's equipment detected subtle signals that earlier missions weren't optimized to notice. But there's also a more unsettling possibility. Mars itself may be far less predictable than we assumed. Beneath its cold surface, slow processes could still be reshaping parts of the planet, movements so subtle they escape easy detection, yet significant enough to affect the data. If that's true, then Mars isn't simply a dead world preserving ancient memories. It's a planet operating on timescales we don't fully understand, changing so slowly that its activity only becomes visible when multiple perspectives are compared. And that idea forces scientists to confront an uncomfortable truth. We may not be asking the right questions yet. Because the more we look at Mars from different angles, the more it seems to resist a single simple explanation. The mismatch between NASA's data and China's observations doesn't just affect how we see Mars. It challenges how we study planets as a whole. For decades, scientists have relied on global models to explain how worlds evolve, assuming that most planets follow a clear and predictable path from activity to silence. Mars suggests that this assumption may be too simple. A planet can appear inactive on the surface, yet still hold on to slow, hidden processes beneath it. If that's true, then our definitions of what it means for a planet to be dead may need to be reconsidered. This has serious implications for future exploration. If Mars can behave differently depending on where and how it's studied, then upcoming missions may uncover even more contradictions. And those contradictions won't be mistakes. They'll be clues pointing toward a deeper, more complex reality. It also raises an unsettling possibility about other worlds in our solar system and beyond. If we can misread a planet we've been studying for decades, then how many distant worlds might be hiding similar secrets? Simply waiting for the right instruments to notice them? Mars was supposed to be a solved mystery, a planet whose story had already been written in stone. But the more data we collect, the less certain that story becomes. If Mars can tell two different stories at the same time, then the real question isn't who's right, NASA or China. The real question is what we still haven't seen. Because Mars may not be finished surprising us yet, and what future missions are about to discover could force us to rethink everything we believe about planets, life, and the fragile line between a world that is dead and one that is merely quiet.